and this video is going to discuss notation, but specifically notation as it pertains to sections of the real number line. So the first example we will see is that we're looking at a number line, and so if I draw this, I need a little picture. I always like drawing pictures. I think it's always helpful for students as well. And I'm going to put 0 in there just as a point of reference. Okay, so then larger than -5, but at most 4. Okay, I don't care about the language because that's confusing right now. I'm just going to put -5 on here, and I'm going to put 4. Okay, and so I'm looking at the region that is larger than -5. So using number order, we know that it's this way on the number line, so to the right of -5. And then for at most 4, it's going to be, well, under 4, right? So it's this section of the number line, and I know there's some marks that need to be made at -5 and 4. I don't remember them exactly. Now, different books do different notations. Okay, so you may have seen this in the past represented in different ways. Some books use dots, or open dots and closed dots. Others use parentheses and brackets. I like parentheses and brackets just because it meshes well with the algebraic notation. So if we're talking about larger than -5, that means we're not including -5, right? So this is just going to say not included. But the language at most 4 includes 4. Okay, because we're saying it can be 4 and anything under. Alright, so the way we represent not included is using a bracket of some kind, okay, a parentheses of some kind, and then again using that other type of notation you may have seen, we would use an open circle. Versus if we include something, that would be a bracket, a square bracket of some kind, or using the other notation you may have seen, a closed dot. Okay, I'm going to use the bracket notation. If you want to use the dot notation, I understand that as well. Okay, so -5, I need a bracket, and I'm going to, parentheses, and I'm going to put the left parentheses because that's the left boundary of my region on the number line. I wouldn't use a right parentheses because it's not the right boundary. Okay, at 4, I'm going to use a bracket, and I'm going to use the right bracket because it is the right boundary. Okay, so graphically that's what's going on, and again using the other notation you would use circles and then line and then a closed dot. Either notation I understand. Okay, nevertheless, so we've represented it graphically, right? Now we need to communicate it algebraically. So with these intervals you're going to be able to express it in 3 ways. Using an image, a graph. Okay, we did that. Using language, oh look, the language is done. Okay, and then the last way is using algebra or symbol form. Okay, so here we go. There's 2 different forms that we can express this in: interval notation and set builder notation. Generally, interval notation is going to be okay. If set builder notation is required, it will explicitly say using set builder notation. Okay. Interval notation looks like this. You're going to have your lower bound, comma, your upper bound, and then you're going to include it using, or you're going to enclose that either using the square brackets or parentheses that I mentioned earlier in the graphical form. Okay, so if we were to do it with our example, the left boundary is -5, right boundary is +4. And then the lower bound, remember we excluded that, so that would be a parentheses, and then the right end, or the right boundary was included, so I would use a square bracket. Okay? Set builder notation, we're going to see something a little bit different. Okay? This is how mathematicians communicate this more formally, and the language that we use is kind of all shown here. Alright? So it would be a curly brace, and I think that's the name I use. Maybe you have a different name. And that means the set of, and then all x. So this just represents a general number, such that, and then x is less than 2. And then so this would just be if we were looking at a number line, and here's 0, here's 2, and I need my my arrows, and I would have something like this for the graphical form. Okay, that's what that means. So we would just put the conditions on X in this region after the vertical bar, and then we would close it with the curly brace. So here in our example, we would have the set of all X, meaning the set of all numbers. Okay, so it's this graph represents all numbers, and then here are the conditions. This number that we don't know has to be more than -5, but less than or equal to 4. Now, this condition right here, these less than or equal to signs need to be in that form. I see a lot of students wanting to do less than, greater than, like to sandwich X to indicate that it's between, and that I completely understand, but that means if you read it like this, it actually means that so X has to be bigger than -5 rather, and X has to be bigger than 4. That's not what the picture's communicating, so we want to just be careful to always make sure that those are pointing the same direction. Okay, and then I would close it with a curly brace. All right, so that's the idea behind set notation. You can use either of these notations if it's not specified. Otherwise, make sure to read directions. So with set notation, you need to be able to express it using language, a graph, and interval or set builder notation.